It's the nutshack. 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 It's the nutshack.
So first off, we got Democritus. Now, he was born in 460 BC, and he lived to be 90 years old. He theorized that, this, all matter is actually made of these, these particles that are really, really small, called atoms, and therefore invisible. And he also theorized that these atoms are indestructible, that they are solid, that they are homogeneous, and that they differ in size, shape, mass, position, and arrangement. That's all well and good, but his theory starts to fall apart a bit when you find out what he thinks of the states of matter. Solids are apparently made of small, pointy atoms, liquids are made of large, round atoms, and oils are made of very fine, small atoms that can easily slip past each other. Democritus also thought that the universe was composed of two elements, atoms and the void which they travel in. And the thing that differed these atoms from one another was those qualitative and quantitative properties. Now, obviously this atomic theory was flawed, it being more of philosophy than actual science, but it did help people back then really start understanding the concept of what an atom was. Now, Aristotle was also a Greek philosopher, but he was born about 100 years later than Democritus, and he didn't believe in the atomic theory, and he taught his followers that the atomic theory was wrong. He thought that all the materials on Earth weren't made of atoms, but rather of fire, earth, water, and air, or some combination of those. Because of this teaching, the atomic theory was actually overlooked for another 2,000 years before people started actually making discoveries again. Now, John Dalton was born in 1766. He was really one of the first to pick up on this whole atomic theory that Democritus had proposed about 2,000 years ago. Now, Dalton proposed that in his atomic theory that everything is really made up of atoms which are indivisible, and the building blocks are the base units of matter which can be destroyed. Now, he also proposed that all atoms of a particular element, such as hydrogen, helium, whatever, are identical, but that the atoms of different elements have different sizes and mass. Dalton proposed that compounds are produced through different whole number combinations of atoms, and that a chemical reaction results in a rearrangement of atoms rather than the creation of atoms or the destroying of atoms. Now, J.J. Thomson discovered the electron of an atom in 1897, and he proposed his whole atomic model, called the plum pudding model, in 1904. And this was before the discovery of the nucleus of the atom, but he still did include the electron in the atomic model. So, in Thomson's model, the atom has a lot of electrons that are surrounded by, this sort of soup of positive charge to balance all this negative charge. Kind of like negatively charged plums surrounded by the positive pudding. Thomson also noticed that an atom could be divided, but unfortunately his whole atomic model was kind of disproven in 1909 by some experiment called the gold foil experiment. Now, Rutherford's atomic model was highly based on an experiment called the gold foil experiment, and his atomic model shows that there is something called a nucleus in an atom, that nucleus has a certain charge, and that charge has a certain magnitude. In Rutherford's experiment, he bombarded alpha particles. If you don't know what those are, they're basically like a helium atom. And he bombarded a bunch of helium atoms onto very thin metallic foils, like gold foil, for example. And in order to record his observations, he used a circular screen coated with zinc sulfide. Now, what he observed with this experiment was that most of the alpha particles just passed through the foil without being deflected, and very few particles actually were deflected when passed through the foil. Now, in his actual atomic theory, he stated that a major portion of the atom is empty, that the whole mass of the atom is kind of concentrated in the nucleus of an atom, and that the positively charged particles are present in the nucleus, that the electrons revolve around the nucleus in like different orbit types, and that the size of the nucleus is relatively very small compared to the size of the actual atom. Now, actually, how he came to this conclusion was that since like most of these helium atoms pass through the foil undeflected, it was concluded that most of the atom is actually empty, and that small angles of deflection indicate that protons are attracted by electrons. Now, because this atomic theory accounted for the positively charged particles, the negatively charged particles, and the nucleus of the atom, many consider Rutherford's theory to be the first sort of complete atomic theory. Now, Niels Bohr is one of the most well-known atomic theorists, and for good reason. I'm sure pretty much everyone in grade 8 has nightmares about the Bohr model. But the Bohr model is actually one of the simplest ways of visualizing the atom. Now, Niels Bohr kind of invented this Bohr model of the atom, and he proposed in this that energy levels of electrons are discrete, and electrons revolve around the atom in these stable sort of orbits around the nucleus, but they can also jump from one energy level to another. Bohr wanted to explain how these electrons can have stable orbits around the nucleus. Now, he saw that in the Rutherford model, the motion of the electrons was kind of unstable. A lot of Bohr's theory revolved around sort of the energy of an atom, and that the energy of an electron in one of its allowed orbits is fixed. As long as an electron remains in its allowed orbit, it cannot absorb or give off energy. Now, if an electron jumps from a lower energy level to a higher energy level, it absorbs an amount of energy, and if it jumps from a higher energy to a lower energy, it radiates or gives off an amount of energy. He also theorized that a spectrum of light emitted from an electron is a line spectrum. Now, where atomic theory starts getting really complicated is when you start looking at quantum theory and the quantum mechanical model of the atom. Now, I'd rather not explain all of this, so I'm just going to go over some key points. First key point. An atomic orbital is the region within an atom that encloses where an electron is likely to be about 90% of the time. Second key point, the Heisenberg uncertainty principle states that you can never know both the energy and the position of an electron. Third key point, electrons have a property called spin, and an electron can have one of two possible values, spin up or spin down, and any two electrons occupying the same orbital have to have opposite spins. Fourth key point. Erwin Schrödinger, I think that's how you pronounce it, proposed this model of the atom, and it treats electrons as matter waves. Fourth key point. Orbitals come in four different shapes: the S shape, the P shape, the D shape, and the F shape. Unlike the other atomic theories, the quantum mechanical model was actually theorized by many scientists such as Planck, Schrödinger, Einstein, and many others. Beware that this is only an intro to the quantum mechanical model. If you want to know more, I'm not gonna teach you about it, but you can definitely find more information. I really hope you liked my project. I was pretty much sick the whole time I was making this, so my voice sounds really annoying. I'm sorry. So I guess I'm done. Anyways, let's cut back to the nutshack in 3, 2, 1.
Nutshack!